This is a session which me and Rikard will try to pull off on JavaOne next week. So it's a sneak peek. We have some more tunings to do, but eventually we will survive. So it's all about, we call it what the backend Java developer doesn't know about the modern web stack. It's a tooling session in the tools track of JavaOne. So not a lot of web framework battle going on. Tooling is the stuff. So we will embark on a small story here, how a developer's life can unravel. Starting with getting this clicker going. So,
well, the first thing we obviously need is a typical Java developer. So, just a safe harbor statement, all names, characters, and so forth are just fictitious. So, this is just a coincidence, right?
We will start our session with this one, Dreyfus model of skill acquisitions. In the 80s, the brother Dreyfus came up with this theory of how students or people in general learn stuff, how they acquire skills. They came up with a couple of steps in a ladder like this, starting with novice, advanced beginner, competent, proficient, and expert.
So we have our nice little Java developer, which happens to be an expert. So everything's fine. So the next step is to do some web work, right? And in order to transform our Java developer to a fully fledged web developer, first we need obviously some cool glasses. Then we need a hat, and we need a beard, and we need to remove that silly Java logo and replace it with some webbish colors, right? And of course, most important, we need to remove that silly cup of coffee, Java coffee.
Yeah.
So we have an expert Java developer, and we inject the web kit, and we're done.
Or are we? We argue that actually just adding the web kit doesn't make you an expert web developer and an expert Java developer doing web. So it's more likely that you're down here because it's a total different set of skills compared to the expert Java developer that you are used to being. Kind of obvious, but it's quite dangerous because at the stage below novice, you actually don't know what you don't know. And that's so the first step is a huge difference.
So this is okay because now you know what you don't know. And obviously it's not as black as white that we have drawn it in these pictures. It's not like you're going from an expert to a total novice, but we're kind of stretching it a bit to make a point though.
So about us, we claim to be up here in at least some galaxy far, far away. I'm Peter, Rikard on the other side, wearing the flag. We're from Sweden, so excuse our Swinglish. However, when we dress in the web attribute, we kind of end up somewhere in the middle here. Advanced beginner or competent at most. So that's our knowledge profile. Squeeders, you know us, you know what we stand for. So today, we're going to try to embark on the voyage of building a modern web application. Featuring me, the web developer. I should have worn a hat, perhaps.
And as a special guest star, the Java developer. And I think it's so nice of you, Peter, that I'm the boring Java developer and you're the handsome web developer.
Shortest straw, you know.
Yeah, thank you. So the first thing we would like to talk about is the structure of an application. And typically, if you come from a Java Maven background, the first thing you would do when you start a project is obviously start with the POM, your POM XML file, and then you start to create your source folder and main resources and put your images under there. Then you have your web app folder with the webinf and your web XML, even though it's empty, because it's always good to have it, you know. And then you have CSS, and finally you have your index file. So that's how I would do it, Peter. How would you do it?
Yes, me as a web developer typically have a much slimmer approach to my project setup. Basically, we serve files to the browser. We don't need to adhere to any component specifications. It's all flat and nice and tidy. So why is this different? Tell me.
Well, the first thing we need to think about is that when you come from a Maven layout, you need to transform that into the WAR layout. And if you're strict with Maven, you would put your images under resources. For a backend system, that would be a resource, right?
Yep. Seems natural.
Thank you, Peter. Okay, in real life, no one ever puts images under resources. You put them directly under webinf or web app, and then you're done. But you get the point. You need to transform your structure into something else. And the next step is to transform your var layout to a var binary format. And then you can feed your container.
Yeah. As compared to us web developers wearing our nice beard and hat and stuff, we simply serve files to the browser. And we know that web apps, modern web apps tend to be quite complex. We had a lot of CSS scripts, among other things, and it doesn't add any value to us to have an even more complex structure.
Okay, the next thing we would like to talk about is how we handle dependencies in an application. And this is something I've done a million times, so I'm quite sure that this is the approach I would do. Obviously, as a Java backend developer, I would recognize that to build a modern web app, I need jQuery to do some fancy user interface, right? So I start my browser and I go to jQuery.com, and then I press the download button, and I put that under my JavaScript folder in web apps. But then I obviously realized that there is some bug, and I forgot to download the minimized files and the map files, so it's a bit hard to debug the error. So I head over to jQuery once more. But what are the odds? Obviously a new release was released, so I need to remove the old one and download all three once more. So that's the process. Actually, I think it smells quite funny to do this, because why do we suddenly put our dependencies under version control system?
Yep, I agree. I mean, meanwhile, you've been downloading, unzipping, putting a lot of third-party stuff into your own source code repository. I've been setting up a small project with dependencies here of my own. So let's see. Hopefully, we can see this. We web developers, we use a tool called Bower for doing this. First, we create a small, just an empty folder to place our stuff in. Bower, we need to initialize with a small descriptor file. So Bower init, we trigger. Putting in some metadata about our application, obviously, because that's important. A lot of stuff in here, looking good. The Bower JSON file turns up in our small folder here. The descriptor file is to keep track of the dependencies we have, basically. So you said jQuery. Let's install that in our small tool here. So bower install -s jQuery pops up in our descriptor file, says dependency to jQuery 3.1.0 under bower components inside my project. We get all the resources that we need. We get the minified stuff, the map files, the debug version, and so forth. Let's see, something else. We need some styling, perhaps, or some great looks to our application. Bootstraps. Bower install -s bootstrap. Done. We got it. And dependency definition updated. Great. What more? Some fonts, perhaps. Images, fonts. Okay. Bower install -s font awesome. That's awesome. Let's see. Whoop, font awesome in place. Great. And the dependencies. Yeah. Found out that we wasn't supposed to use the latest version of jQuery. What versions do we have to choose from? Let's see. Bower tells us, yeah, that's a bunch of versions. Let's pick the 3.0.0 version. Bower install -s jQuery hash. Okay. So obviously we have a different dependency now, but I want to resolve it as the first alternative here, 3.0.0. Okay. Downloaded and the dependency is updated. That's how we deal with dependency management. So package managers, we all know of, basically tools to share and consume software libraries and the dependencies.
So first off, just a quick history lesson. In 1977, Make was released, and in 2000, Apache Ant was released, and then the accident Maven 1 was released 2004. And then we got dependency management using Ivy, which you could combine with Apache Ant. And then we got Maven 2, 2005, and Gradle 2009. The topmost, we won't look at them. I mean, Make is not even about dependencies, but it's old at least. So this talk will focus about Maven and Gradle mostly, or use them as a reference, that is. Yeah. And if we look at the tools that we're going to talk about, the Node Package Manager, NPM, was released 2010, and Bower released 2012. So those tools are quite more new compared to Maven. So when you're dealing with Java, you more or less have to make a choice about Gradle or Maven.
But being a web developer, you're more of choosing Bower and NPM. So we have two dependency managers, basically. And how's that? NPM, as Rikard introduced here, is a package manager introduced by the Node.js community for sharing and reusing JavaScript, basically. We use NPM for tooling, doing web development. Dependency to the tools we need to efficiently develop web applications, such as build systems, preprocessors, and all that funky stuff. NPM has this nested dependency resolution, meaning that you express a dependency to one tool, and in the back, that in turn makes you dependent on other tools and so forth. So a nested hierarchy. NPM 3 tries to resolve this, but it's still nested in many cases.
So the size of an application is not an issue if you're doing a server-side application.
However, for web apps, we are quite aware of the size of our application. It's a real impediment toward the user experience to have too much stuff going over the line. So for web development, we need Bower, dealing with the stuff that goes over the line, like the web stuff we need. We need Bower, and Bower is dependency management for the web.
I guess we should add a safe harbor statement here. You could use other package managers as well. There are, I mean, the web landscape is changing so fast. So tomorrow there will probably be some other tool that is the most hip one.
Yep.
But Bower at least serves as a good purpose of the tool you need for this purpose.
Definitely. So Bower uses NPM as its storage. This was introduced by Twitter, 2012, we heard. So Bower, for your HTML, CSS, JavaScript fonts, and for such dependencies, the stuff that goes over the line. Bower uses flat dependencies, meaning you express dependency to one library. You don't get all the dependencies that you need in order to use that library, so you're pretty much on your own dealing with resolving all your dependencies. Doing the analogy with what we know from the server side, we have Maven plugins, tooling stuff, pretty much like the NPM stuff. And the Maven dependencies, the stuff we need in our application. That's what Bower does for us.
So if we take a look back at Maven, it has, just as NPM, a nested dependency tree. So to summarize, flat versus nested dependencies. You use nested dependencies for like Java tooling, modules, and that's Maven, NPM, that's for the server side. And you use flat dependencies when the size matters for web, CSS, fonts, and that's Bower. So the next thing to talk about is task runners, and we have those in Maven as well. We call them build phases. It's like you have Maven clean, test, install, deploy. There are different hooks where you could execute things that you need to do in your build process.
Yeah, web stuff. We do a lot of stuff with our web apps these days. A lot of pre-processing. We process HTML or markup, whatever markup we choose, our script stuff, CSS, a lot of stuff. We use, we verify our applications in many different ways. We package it, we massage it in different ways. Want to show you a couple of scenarios here where task runners excel in web app development. Starting off with our small project here. We have our Bower components we discussed earlier, our node modules, the tooling dependencies, a lot of stuff. And the Gulp file, meaning that we use, in this case, a task runner called Gulp. To verify our application, doing unit testing on our JavaScript code, we use Gulp, naturally. Executed 18 out of 18 tests here with one command. Doing test-driven development, we typically have a more flow-oriented feel to the workings. Task runners excel as well. We start Gulp here with test auto, and see what it serves us. We have some funky creation data here in the file. Let's remove that. Saving the file, instantly the task runner kicks in, running all the tests. We can see we have something failing here. Obviously, there was a test failing. Let's remove that one. Save again, and instantly it executes all our tests. Just to exemplify the workflow that we aim for here.
I kind of like that you pick up the backend way of resolving failing tests.
Yep, I'm learning quickly here. So let's demo some end-to-end testing here. Use a tool called Protractor for this currently. in this case. We trigger our task run here to initiate the end-to-end tests. It pre-processes our application, starts up the application on and exposes it on a port here. It pops up a browser and uses the Chrome driver here to execute a couple of tests against our application. 2 specifications, 0 failures. So at least it works in some sense. So task runners we use to automate everything that is possible to automate. For web development, that is a lot. A lot of tedious tasks that we used to do manually or trigger stuff in a repetitive flow. We use task runners to automate these days. So the 2 big kids on the blocks, there are definitely several others, but currently are Grunt and Gulp. You can see represented here. And comparing Grunt and Gulp is pretty much like comparing Maven and Gradle. You have configuration versus code. There's a bunch of other features as well that differs in significant ways, but as a developer, that is one main choice. And you choose whatever works best for you, as long as you have some kind of task runner. So doing the analogy here again with the backend stuff that we are aware of as the backend developers, we have Maven plugins. That's pretty much the tooling stuff that Grunt and Gulp plugins serves us in the web stack. Maven build phases, that's Grunt tasks, the declarative stuff. And Gradle tasks, that's more like the Gulp tasks.
So part two of the history lesson. Grunt was released 2011 and Gulp was released 2013. So let's take a look at perhaps the most important thing here when we come to this presentation, and that's about the development workflow, how to be a productive developer. So as a Java backend developer, I just need to add those funky JavaScript to my source code, so I include them, reference whatever in my directory folder, and then I realize, okay, it wasn't a good approach, but nevertheless, let's keep moving. The problem is when I need to change my versions, when I put my scripts or my resources under version source control, I need to change all the includes for all files that has that reference. That's a tedious job. But let's forget about that problem. I heard about some tool called Bower there. So let's add some CSS. So I add my amazing CSS. Should be a shocker. Then I add Tomcat to my POM, so I can start my container. Then I do Maven clean install, and then I start my Tomcat using Maven Tomcat run, head to my browser, press F5, and I see the amazing result. And I can see you're really impressed, so let's tweak the background color so it's even more amazing. So I like the papaya whip, so I change my CSS, I do Maven clean install, I do Maven Tomcat run, head over to the browser, press F5, and I look like that, and oh my god, do I really need to move something 1 pixel?
I'm afraid so. I'm afraid so. How do we go about this during web development? So let's see. We use our task runner, in this case Gulp as well, to serve our application. Popping up the application, let's see, we want to adjust some look and feel here, or some looks at least. The background color, let's see, white, no, red perhaps, save, no, red, not good. Let's see, do we have some other, blue perhaps? No, not good. Orange, save, instantly. Yeah, like the orange. Like the orange. So, small fix. Let's update some text here into some localization files. Okay, save, instantly reloads. Yeah, no new text. Looking good. So I hope you have the backend workflow in mind here. So let's see. We have a small library here called Moment.js. I've heard we were supposed to remove that. We use Bower to manage our dependencies. So let's tell Bower, uninstall this moment thing, Moment.js. It uninstalls it, reloads it, and it's gone from our index page. We add it just to see that nothing was faked here. Add it, it resolves it, and it's in our index page again. So that's how we deal with dependencies and updating our resources. We tend to do responsive design these days, meaning that we need to support different screen resolutions or screen sizes. The thing is, it's troublesome to work with. But we use our tool Browser Sync that is seamlessly integrated to our task runner here, making it possible to interact with one browser, having all the events synchronized across a set of browsers. So we can edit stuff in one, but see the results in several browsers. That's quite a productivity gain compared to trying out, doing a change, trying it out in different browsers, doing a change, and so forth. So that's the typical web workflow.
And the browser thing task runner that you saw, it's not limited to Chrome. You could use all browsers that you like. You can use it on an iPad as well, and you can see all your devices simultaneously. So that's a really, it actually looks good, Peter.
It does,
yeah,
doesn't it? So, I mean, at the first glance, web workflow seems to be quite equal to JavaEE workflow, at least some extraction. We write the code, but in the real world, it's really a huge difference, as you probably could tell. Web development is a lot about visual inspection or adaptation to whatever you see in front of you. We need that fast turnaround, fast feedback loop that a task runner provide us. We code, build, test, preview in a smooth operation. So.
And the reason why it's different is when we write a backend application, we have a more linear process. First we write the code, then we build and test, change to command line, then we deploy it to the container, and then we can preview the result. And of course we know about all the great tools that exist, like JRebel, that kind of improves the build cycle, but still, at the end of the day, this is how the language or the tooling is designed. So you should use those tools, but you won't get that productive workflow anyway. And it could actually be even worse. It could be like you have to do Maven install, Maven deploy, and your CI server is building it, and then you do integration test, performance test, and then you publish your artifact, and then you build your container and publish your container, and then you deploy your container, and then you can preview your result. That was a rant. So the next interesting thing to talk about is scaffolding. And this is perhaps a feature of Maven that is not that well known. It's called archetypes. So basically it is something that will create a skeleton for you. So you just provide it with your group ID and artifact ID and you tell them the name of the archetype. So in this example, we're going to create a JavaEE, a simple JavaEE skeleton application.
I mean, we web developer with our fancy hats and all that stuff, we love scaffolding a lot. So let's see, let's scaffold a small app here. For scaffolding, we use a tool called Yeoman. Let's see. Scaff demo, new folder here. Yeoman, let's install some generators. I've heard about Angular, driven by Gulp here. Let's install that. Gulp Angular generator, fetching, downloading the internet and friends.
So I recommend this step from Maven.
You do that, yeah. We love downloading stuff as well. So let's see. Here we go. Let's trigger it. Which version of Angular do you want to use? 1.5 seems good. A lot of other choices here to use Bootstrap and ng resource, and we want to have standard JavaScript in this case. A lot of stuff, basically. We should pick and choose what technology that applies to our case in this application. As you can see, a lot of stuff is generated for us, and npm and bower is triggered here to pull down all the necessary stuff that we need. Let's see. This takes a while. We should perhaps speed it up until next week. As we told you earlier, npm pulls down all the tooling that we need, all the pre-processing and build tools and such. Bower, in turn, pulls down the web frameworks that we need to use for our nicely scaffolded application here. There you go, all the dependencies required. Moment, doesn't take a moment though, it seems. Here we go, done scaffolding. Let's see what it looks like. Gulp serve. Here we go. Yeah, that's our newly generated application. So that's how we do scaffolding on the web. Yeoman is a small man with also hat and a great mustache. Basically, this is project scaffolding for the web apps, which not only comprise the web app and the example application, but also all the tooling, the workflow that makes you productive. So that's the essence of Yeoman generators. And in fact, Yeoman equals archetypes.
Yeah, they seem really similar, but first let's take a quick history lesson, part 3. As we all know, Maven is quite old. It has, is it 7 years advantage over Yeoman, the Yeoman thing?
Yeah.
So if we would translate that to internet time, that would be like 18,000 years before the current era. So I bet your Yo thing cannot beat Maven archetypes.
Yes, let's see.
Well, surprisingly enough, if we look at the number of generators that exist, so Maven has 1,600 generators, and Yeoman has at least 3 times more in such a short period of time. And I guess the reason is that you could consider Maven archetypes to be old legacy, and it really doesn't have a good ecosystem. There's no good way at least to find what archetypes that you would like to use. You have to know it. There's no marketplace. You cannot search for the most popular ones. Basically, it's like the tool vendors are forced to create their archetype, and then you read that on their tutorial page, and then you go. So, and if you would use a Maven archetype to create a front-end application, you typically would do it the back-end way.
Yeoman generators, on the other hand, is sporting a vibrant community. As we saw earlier here on the numbers of generators, it seems like something is really going on in the community of Yeoman. And actually, it's used as well, as compared to Maven archetypes. And the ecosystem is awesome. You got websites, you got rankings, you got stars, you got all that fancy stuff that we webstar developers like. And it's for front-end stuff, mostly, we should say.
So it might be a bit ironic that the future might give you that you would require Node and NPM to create your Java project. And I think if you're about to start writing a Maven archetype, you should at least consider or evaluate Yeoman.
You should. So we're down to conclusions. We have this analogy going on. Let's continue with that. We know what Grunt and NPM and the Bower is compared to, dealing with the stuff we know. And Yeoman is pretty much like Maven archetypes, but usable. So by this time, we hope to have proved the point that backend tooling is not a perfect match for web development.
And a few reasons for that. The structure of a web application is not the same as, for example, the Maven layout. The Maven layout is more complicated. There's no reason why you should force that layout into your web project.
Dependency management is important. It needs to be handled that way that we used to handle our dependencies on the backend side. And it needs to have a flat dependency hierarchy.
And then the workflow is also very different for a web application and a backend Java application, where Maven kind of force you into a more linear process, where you on the web need this tight feedback loop.
And scaffolding for the web is awesome. Talking about Yeoman, you can pretty much generate all example applications, including workflow for all web app technologies known to mankind. Most likely, you should try it out. So, down to conclusions, we think that the rockstars of web development use some kind of dependency mechanism and task runners to be productive and manage their code efficiently. Okay, so you might be convinced, but how do you convince your backend team to do this stuff? I mean, they are pretty much the one who decides the process, the build process.
And the key thing here is that you have, between the front end and the back end, you have an API. So you should strive for having a separate release of your back end and front end. And if you have that, there is really no reason why you couldn't use the right tools for web development and embrace that workflow.
So, bearing this in mind, one key point could be that you should not wrangle your front-end code into your back-end build process. We are beyond that. So, hopefully, we have turned the ones of you who didn't know what you didn't know.
That's me, I guess.
Yeah, that's you. From this area up to the novice area here. Now you know what you don't know, and you know what you should start investigate on your next web project.
And if you would like to use some best practices, we would recommend you to use this guy. And this is a Yeoman generator called JHipster, which has assembled all the toolings and all the things that we have talked about here. So it's a really quick way to get started using Gulp and Grunt and all those things in a nice assembled package.
Yeah. And not only a web frontend, it actually marries the effective workflow of the web developer with an effective workflow of a backend developer, because it also comprises of a Java backend. So you can see how that stuff plays together.
And it also does microservices.
Yes, and a lot of other stuff. So basically, the mission here that we want to leave you with today is that you should experiment with JHipster. It's easy to get going, and you will get enlightened in so many ways. Okay, okay.
So, questions, please.